So here I am, just about getting started on a good rant about memorizing formulas and things when my 15-minute time limit per video runs out. Okay, well, here we go. Maybe a little bit of a rant, but probably less flamboyant as I was about to be when my time ran out. But this formula for calculating y bar just bugs the heck out of me because it does not look like a calculation of moment divided by mass. This does not look like a distance times a weight. This looks more like outside radius squared minus inside radius squared. It looks like the calculation of a volume of revolution washer method, except that it doesn't have a 2 pi out in front. No, it was supposed to have a pi out in front. Here it's got a half in front instead. But it doesn't look like moment to me. And I remember learning this, that this never stuck with me. I always had to try to do something some other way because I didn't understand this formula because it just was not a moment calculation. However, if you're trying to learn this and you're trying to remember things, I would much rather you think of it in terms of this function up, this integral up here, because this to me is a distance away from the x-axis. It's the middle of the rectangle, the y value in the middle of the rectangle. So that distance away from the x-axis times the area of the rectangle. So you've got a distance times a weight. And that to me feels like moment. Now it just so happens that when you multiply this out, oh yeah, it looks like this down here, which is all fine and dandy. But if you try to remember this down here, it doesn't, the formula doesn't lend itself to recreating it, where this formula up here is definitely recreatable. So let's do some examples and see how this works. So I want to start with, my favorite region. Let's do the region bounded by, above by the curve y equals x, and below by the curve y equals x squared. Between 0 and 1 right here. So this region, I want to find the center of mass. And actually that little blue dot may be very close to the center of mass right now. But let's see. So x bar is calculated by an integral from 0 to 1. I got no density function. I'm assuming uniform density, so I don't have to worry about the delta. So x bar is calculated by each rectangle. You've got to figure out how far away from the y-axis it is. Well, that's the x value, times whatever its weight is. Well, in this case, we can just use area. So the top function is x minus the bottom function, x squared, dx. And then we have divided by the total weight, or in this case, the total area. So that's just x minus x squared dx. And so we can do some calculations here. So on my calculator, I've got the integral of x times x minus x squared dx from 0 to 1. Enter, and it tells me. So the numerator, maybe I can get that as a fraction. Let's see, math, fraction. Yeah. So the numerator is 1/12. If I get this to look right, 1/12. Divided by the denominator. So this is now the integral of x minus x squared dx from 0 to 1. And it gives me that, which I believe is 1/6. Let's try this. Yes, 1/6. For a grand total of 1/12 times 6 over 1, which would be 1/2. Now first thing I do is I look at that number and I say, is it even in the realm of possibilities? I'm looking for x's between 0 and 1, and it's telling me x equals 1/2 is the x coordinate of the center of mass. Well, if it turned out to be 2, there's no way that's going to be. There aren't any x values over there, right? So a half, yeah, it's in my range. The fact that it's right smack dab in the middle, that's a little surprising to me. This isn't always going to happen. And it's not going to be right in the middle, but somehow, even though the shape is different over here than over there, because this parabola is horizontal, and this, so the angle between those two is is 45 degrees, right? Slope of 0 and a slope of 1. Where over here you got a slope of 1 and a slope of 2. That's not 45 degrees, that's less than 45 degrees. So this is pinched more than that is. I would almost expect there to be more stuff over here, but somehow it turned out to be right smack dab in the middle. Let's calculate y bar now. So y bar is the integral 1/2, and I'm going to write it out like this. I'm going to write it out as the top function plus the bottom function divided by 2. That's the average value, times the top value minus the top function minus the bottom function times dx. That's the area. Integrate from 0 to 1. And now divide by that same denominator. Well, I've already done that, so let's just write that as 1/6. So when you divide by 1/6, it's like multiplying by 6. So the 6 times a half is going to be a 3 out in front. So I've got 3 times this integral. Now, if you do multiply it out, it would look like x squared minus x to the 4th. What the heck is going on here? X to the 4th dx. So we got to figure out what that is. And I type it into my handy dandy calculator. So here we go. We've got it x squared minus x to the 4th dx from 0 to 1. Enter. And it tells me 1.333. What is that as a fraction? It is 2/15. Okay, 2/15. So back over here, this is 3 times 2/15, which would be 2/5. Does it seem reasonable that the answer should be 2/5? At this point right here is the coordinates 1/2, 2/5. Well, the 2/5 is less than a half. So this is the line y equals x. So the point right here would be the point a half. And so, yeah, I would expect this is all down below that line. I would expect the center of mass to be below the edge there. And it is at 2/5. Okay. So there's that center of mass. Do I have time to do one more? I do. I'm going to do another one. So let me just x bar, y bar on this thing. The center of mass is 1/2, 2/5. All right, one more. Let's do the region here, one bump of the sine curve. So let's take the sine curve. So this is y equals sine x on the top, and we'll do, the x-axis, y equals 0 on the bottom, from 0 to pi, and find the center of mass. It would seem to me it should be right about there. On this one, now I lucked out last time. I lucked out that this x bar happened to be right smack dab in the middle. There was not symmetry to support that. Right? In this case, I'm going to say that I can look at this thing, and as long as there's no odd density function, and I'm just going to tell you that for this problem, I'm taking uniform density. I just want to calculate the centroid. Where is the balance point for this region? I can argue that it looks just the same on the left side as it does on the right side from this midpoint, pi over 2. I'm not going to calculate x bar because by symmetry I can see it's pi over 2. I am more than happy when you're working on problems for you to be able to look at a region and say, hey, this is symmetric about, this line right here. So this line right there, it's symmetric. So it's got to be the x bar is here. If you can see that, great, saves you work. Okay. So let's just calculate y bar. So y bar is 1/2 the integral from 0 to pi of the top function squared minus the bottom function squared dx divided by the area of the whole region. So the area of the region would be the integral from 0 to pi of sine x dx. This one I've done enough times that I know that's equal to 2. Oh, I've got a couple. What am I going to do here? It's equal to 2. Yeah. Well, okay. I was going to draw some pictures, but let's just type it into the calculator. Let's do that numerator. Typed into the calculator. So I've got the integral of the sine of x all squared dx from 0 to pi, and I hit enter, and I believe the answer is 1.57. That looks to me like pi divided by 2. I'm just going to quickly check by multiplying by 2. Yes, okay, it's pi divided by 2. So over here, this is equal to pi divided by 2. Oops, I forgot about the half out in front, so let me put that in there, times a half. Then divided by this integral down the bottom. And this integral is 2, but let's check that on the calculator. So this is the one I had before, and so now I'm just going to get rid of the squared on that thing. So delete, delete. Now I've just got the integral of sine x from 0 to pi, and I go and it tells me 2, sure enough. Okay, so this is divided by 2 for a grand total of pi over 8. Pi over 8. How much is pi over 8? I don't even, it's like, well, I do know one thing, right? Pi is like 3, so pi divided by 8 is going to be, well, in the vicinity of, well, less than 1 anyway, even less than a half. So that's in the right range. My y values are from 0 to 1, so to get something that's less than a half, my centroid is down here somewhere. And let me just quickly double check what pi divided by 8 is. Pi divided by 8 is 0.392699. All right. A little over 1/3. So when I look at this and I say, does that make sense to me that the x bar y bar is equal to pi over 2 comma pi over 8? Well, the pi over 2 by symmetry, yes. The pi over 8, there seems to be more, this is wider down the bottom here than it is up at the top. So I see more mass down below than I do up here. So yeah, that's going to pull that center down lower than a half, almost down to 1/3. Well, about 0.4. Okay. Anyway, there's center of mass. If you have sideways regions, if you have regions where you're bounded on left and right by different functions for some y value between c and d, well, it's exactly the same thing, but with x and y reversed, right? This time you're going to be drawing horizontal rectangles, so the y bar is going to be the easy one, because that's just going to be y times the area. The x bar is going to be the more complicated one, because you're going to have to figure out the middle x value, so right plus left divided by 2, to figure out where that rectangle is sitting on the x-axis. But it just interchanges the roles of x and y. In fact, I've seen many people on problems like this just say, I don't want to do it that way, I want to do it this way, and they turn the whole thing over and they say, oh, it looks like this, and they put the c and d down here, and they calculate it in terms of x bar and y bar like this, and they say, oh, but I flipped it, so flip it back again. And regions of type 2 are very similar to regions of type 1. You just interchange the role of x and y.